name is Reagan, and today we're going to be doing experiment 3, determining a chemical formula via titration, specifically the chemical formula of calcium in water. But first, we're going to be experimenting with calcium, a group 2 metal, and zinc, a transition metal, in water and hydrochloric acid to observe what kind of reactions take place. When we add an active metal or an alkaline metal such as calcium to water, there will be a reaction that takes place forming hydrogen gas and hydroxide ions in the water solution. When we add calcium and zinc to a hydrochloric acid solution, there will also be a reaction that takes place that will produce hydrogen gas as well. The reason for this is that the metals have extra electrons in their outer shells, in their S shells, that they can donate to hydrogen to form hydrogen gas and thus remove it from water. More active metals such as sodium metal will have very violent reactions with water, even at room temperature. But metals in the group 2 column of the periodic table will have milder reactions, but will still react readily with water such as calcium, barium, or strontium. So first we're going to be showing these reactions of calcium with hydrochloric acid and zinc as well. Before we do so, we need to make sure we observe proper lab etiquette and protocol for our safety. That means wearing safety goggles, gloves, a lab coat buttoned all the way up with no skin showing below the waist. That includes wearing long pants and closed-toed shoes. And any loose hair needs to be tied back as well to stay out of the way of the experiments. Make sure that you do not eat or drink in the lab and do not smell or taste any of the chemicals that we'll be using in this lab. For the first part of the lab, we're going to be using calcium metal, zinc metal, hydrochloric acid, some test tubes, a balance, and weigh paper, as well as matches. So to begin, we need to add 6 milliliters of 6 molar hydrochloric acid to a test tube. Next, we're going to weigh out 0.5 grams of first zinc and then calcium metal on a balance, or this small scale. So first, you want to crease a piece of weigh paper, like so, in half. This makes it easier to deposit the metal into a test tube after weighing it, and you can set it on the balance and then tare it once the numbers settle out or stop moving. Once the balance itself is at 0, you can then add, first beginning with zinc metal to the balance until you have 0.5 grams. Record the mass of the zinc in your lab book and then add the zinc to your test tube with hydrochloric acid in it and observe the reaction. So what's happening is the zinc is reducing the hydrogen in the solution and forming hydrogen gas. If we now put this underneath another test tube, we can collect the gas that is being deposited, or that is being produced, into this test tube, which is hydrogen gas. Hydrogen gas is flammable when combined with oxygen and a match, and we will perform that here next. So after about a minute or so of allowing the gas to be collected in this upper test tube, you can then have a partner light the match for you and see what happens. So after we perform the experiment with zinc, we're going to repeat the experiment with calcium, but we're going to use less calcium this time. First, we want to add 5 milliliters of 6 molar hydrochloric acid to a vial, or to a test tube again. After we have measured out the hydrochloric acid into a test tube, we can then weigh out 0.1 to 0.2 grams of calcium metal on the balance. Record this number in your lab book and then carefully slide the metal into your test tube and watch the reaction take place. Make sure you use tongs for this part, as the liquid portion can be very hot. As previously, collect the hydrogen gas that's being produced in another test tube. Again, have your partner light a match quickly and then add it. If the hydrogen in your test tube did not ignite, try again by holding the test tube below the other test tube for a longer period of time and then quickly lighting it with the match without delay. So for this part of the experiment, we're going to be observing the reaction between deionized water and the metals when we add them to test tubes. So first we're going to need 2 test tubes, both filled with about 5 milliliters of deionized water. And then we're going to need to weigh out 0.5 grams of zinc for this first part. We can then add this to the test tube. So unlike the hydrogen chloride or the hydrochloric acid reaction, zinc is very stable in water, as you can see. So you can leave this for a little while and observe the reaction to see if any hydrogen is produced, but most likely none will be. So for this part, we're going to need around 0.1 grams of calcium, but you can use less, 0.05. Once you have it weighed out on the balance, you can then add it to your other test tube with water in it and observe the reaction. So unlike the zinc in water, calcium, with its 2 outer electrons that are easily removed from calcium and donated to the water solution, quickly forms hydrogen gas and calcium hydroxide. So we want to let this go to completion until there are no more bubbles being formed. After the solution has stopped forming bubbles and the calcium metal has been consumed, you'll be left with this white precipitate, and we can then add it to a small beaker, like so. Once we have the solution in the small beaker, we can add 2 drops of phenolphthalein indicator, which will produce this bright pink color. Phenolphthalein indicator is pink when it's in basic solutions, but it's colorless when it's in acidic solutions. So slowly we're going to add drops of 6 molar hydrochloric acid until colorless. After we have added the 6 molar hydrochloric acid and the solution is now acidic, you will notice that it is clear in color, which means that the phenolphthalein indicator is an acidic environment. That concludes this part of the experiment. The next part will be a titration, where we determine the amount of calcium that we have added to a solution of water. So in this part of the experiment, we're going to be performing an acid-base titration using calcium metal and water. We will first add calcium metal to water in an Erlenmeyer flask, which will react, forming hydrogen gas like before, and also calcium hydroxide. This will be the base. We will then add a standardized solution of 0.3 molar hydrochloric acid to the burette, which will be the acid that will be titrating into the base. The indicator we're going to be using is thymol blue. So as we titrate the solution, it will tell the amount of acid that we add to the basic solution that we're going to form with the calcium metal will be able to tell us how much base was in the solution. Knowing that number and knowing the exact amount of calcium metal that we've added to the solution will tell us how many moles of base or hydroxide ions were formed for the number of moles of calcium atoms that we have added to the solution here. So to start with this experiment, we're going to first again need to weigh out a mass of calcium metal using the balance. So once we have recorded the mass of calcium, you need to write down this number in your lab book so that way you can use it later in the calculations. We can then take the weigh paper and add it to 150 milliliters of deionized water in an Erlenmeyer flask. Like before, this will produce a reaction where it produces hydrogen gas and calcium hydroxide. You'll need to wait until the reaction has stopped and all of the calcium metal has been consumed before proceeding with the titration. So once all of the calcium metal has been consumed, we can then add 10 drops of thionyl blue indicator to the Erlenmeyer flask. Before starting the titration, we need to first rinse the burette with a small amount of the 0.3 molar standardized hydrochloric acid, like so. So just add a small amount, maybe a couple milliliters or so, until it reaches the first gradations on the burette. Remove your funnel and then allow the solution to cover all the parts inside of the burette. After rinsing the burette like this, you can then dump out the hydrochloric acid into a waste beaker. You need to do this 2 or 3 times. It is good analytical practice in order to prepare the burette for your titration. After rinsing the burette, you can then add your funnel back to the top and then fill your burette up to the top like so. It is not vital to fill the burette exactly to the 0 milliliter mark. You can stop short a couple of milliliters and then just determine your starting volume by reading the gradations on the burette. Once you have determined your starting volume, you can then start your titration. So once the solution has become a pale yellow color, that you have reached the end of the titration and you can record your final volume to use in your calculations for the rest of the lab. If the solution color is more of a red color or a pink, you have overrun the endpoint and you need to repeat the titration and get that nice pale yellow color. That concludes the lab for today, and I'll see you in the next video.